So the third atomic model, which is proposed by Mr. Niels Bohr. So he is actually is like recent times, even after independence, 1962. He's alive up to 1962. So even our Indian renowned scientists, many of them even they have been worked with him, like Mr. Uh, Bose, not Subhash Chandra Bose. There is a scientist name called it as a Bose. Even that is also the fifth state of matter, which we used to call Bose-Einstein condensate. So, like many known scientists, it has been there. So, a Bohr's atomic model proposed, Niels Bohr proposed his model in 1913. So, please write it. Bohr's atomic model. So, in 1913, in order to overcome the limitations of Mr. Rutherford model, he gave the concept of orbits, discrete states, and as well as energy levels. So if you notice it, the limitations of Rutherford, he failed to explain why the atoms, even though they are continuously accelerating, why they are not losing the energy, and why they are not falling into the nucleus. That is what is our we studied. Am I right, guys? Please respond, all of you. So that is what is our major limitations of Mr. Rutherford. So to overcome that thing, Mr. Niels Bohr came with a concept of three things. That is what a concept of orbits, and then discrete state. We'll discuss the energy level. Discrete state, or that is what we used to call it as a energy levels. So with these concepts, he has been trying to overcome the limitations of Mr. Rutherford. So, from that, he has started forming the postulates of Bohr's atomic model. So, what is exactly he is saying? And that is all we are going to discuss now. So, if you all observe very carefully here, right, keep heading next. Postulates of Bohr's atomic model. Postulates of Bohr's atomic model. First point. The first point which will speaks about the Bohr's atomic model is, so as we all knows that Rutherford said that electrons are not at stationary. What the electrons are doing, everybody? They are revolving around the nucleus. Is it right or wrong? All of you? So that is what is the same thing here. So the electrons revolve around the nucleus in a closed and circular path. You all can notice it here. Closed and circular path, which are we used to call it as orbits. What we used to call, all of you? Orbits, or we used to call it as a shells, or we used to call it as energy levels. So that is the first postulates of Mr. Bohr's atomic model. So please write it. The electrons revolve around the nucleus. The electrons revolve around nucleus in a closed path, in closed circular paths, which are called orbits, or we used to call it as shells, or what is another name, everybody? All of you? Energy levels. Do you understand, all of you? Now, this is the first point. Second point. And the second point he said is the total atomic mass, the mass of the atom, protons and neutrons are present at the nucleus, and that nucleus is the responsible for total mass of the atom. And nucleus is positive charge because of presence of protons. That is what is the second postulate of Bohr's atomic model. So what is the second postulate, everybody? The protons and neutrons are present in where, everybody? The protons and neutrons are present in nucleus. So the protons and neutrons, this is what is called as nucleus. So please all of you remember. So the protons and neutrons are present in present in present in the nucleus, which is responsible for, or which are responsible for total mass of the atom. So that is why yesterday I said you total mass, atomic mass will represent with one letter. Anybody can tell me what is the atomic mass is represented with? I'm asking you, you all
A,
to tell. No other way. Yes, please. Everybody.
A,
So atomic mass is A, atomic number is Z. Atomic number means number of what? Everybody. Number of protons.
Protons
Atomic
plus
mass means number of protons plus
protons plus
number of
neutrons. Number of
neutrons. That is what we used to call it as. And you remember now I'm saying a mass of proton, of course, tomorrow's class we'll see. Mass of proton is equals to approximately mass of neutron. Do you all understand, everybody? There will be a small change, but that difference is not considered. But we'll consider averagely mass of proton is equals to mass of proton is equals to mass of neutron. That is what you have to remember. That is why the atomic mass of any atom, we will consider sum of the protons plus neutrons. So hope you all clear. Any doubt you can ask me. So the second postulates of Mr. Niels Bohr, the Bohr's atomic model is the protons and neutrons are present in the nucleus, which are responsible for the total mass of the atom. And who is responsible for positive charge of the nucleus? Everybody, who is responsible for positive charge of nucleus? Yes, please. Nobody? Who is responsible for positive charge, guys? The positive charge of nucleus is due to the whom?
proton.
Protons. The positive charge of nucleus is due to protons. So that is the second point. All of you write it. Next, third point. Each orbit has a fixed amount of energy. So we are having different orbits. So now you draw this diagram also, you can fix. So each orbit, let me take it is not 1, E1. It is not 2, E2. It is not 3, E3. And this is what? E4. E4 means E1, E2, E3, E4 means they are actually energy levels. So that is only the third postulates of Mr. Niels Bohr. Each orbit has each orbit has a fixed amount of energy, a fixed amount of energy, not same amount of energy, different energy, but that is fixed for that level energy. Therefore, orbits are also called it as, therefore, orbits are also called it as, what we used to call, what is the third name? Everybody. Also called, what we used to call, guys? Everybody. Energy levels. Okay. So that is the third point. Next. Fourth point. The electrons do not change their energy levels. The electrons do not change their energy levels under normal conditions. Means when they are revolving around the nucleus, so that is a normal conditions, unless you provide more pressure or temperature or some other extremely high heat. So then the electrons, they will start radiating energy. But at the normal conditions, the electrons never radiate the energy. That is what you have to remember. That is the reason they will never fall into the what? Nucleus. Do you all understand? Mr. Mari, clear, Lingesh, everyone?
Yes, sir.
Yes. The electrons do not change their energy level under normal conditions. Normal conditions. But if you change the conditions, like you can take extremely hot, extremely high temperature, pressure and all. So by that time, then electrons will start radiating energy and they will be coming out. Do you understand? We can even separate the electrons from them. So that is you should remember. Everybody clear? All of you? Yes, please.
So
Yes,
will
sir.
it differ from each environment?
Yeah, we can. That is no normal conditions. It will be normal conditions means at normal, well, like suppose if you can consider room temperature, room pressure, everything, whatever it is, normal temperature and pressure and all. Okay.
Yes, sir.
Yeah, that is all. So please make it. So right, when energy is given, when energy is given, when energy is given, the electrons get promoted, the electrons get promoted to the higher energy level, to the higher energy level, and when the source of energy is removed, and when the source of energy is removed, the electrons come back to their electrons come back to their original state by releasing energy. Do you understand, everyone? If you give more energy, they will attain the more state, higher energy level. And if you just stop supplying the energy, if you remove the source of energy, then what will happen? They will release that energy and they will come back to their original position. So original level. That is only the things. If you provide more energy, they will attain the higher energy level. If you remove that, they will be come back. That's what you have to remember. Is it okay, guys? Everybody clear? All of you? Yes, please. Yes.
Yes,
Next.
sir.
The energy level may be like we can say is, designated as, we can give to the numbers 1, 2, 3 or 4, or we can give the designated numbers like K shell, L shell, M shell and N shell. K, L, M, N, or we can give 1, 2, 3, 4. So that is what is the energy levels. So we can assign the numbers or letters. Basically, we'll study K element or we will study 1, 2, 3, 4. So each one is not same energy, different energy. So note it. The energy levels may be designated as 1, comma 2, comma 3, comma 4, or of course, if it is there, till now the known elements, more than fourth level, it is not going. Suppose future, some other elements may be discovered or it is formed, then maybe the next level will come. And the remaining K, L, M, N. So either 1, 2, 3, 4 or K, L, M, N. That is what you have to remember. So energy level 1, E1, 1K, E2, 2L, E3, 3M, E4, 4N. So 1 means L, note it, 2 means, sorry, K. 1 means L, 2 means L, and 3 means M and 4 means N. So you can write either K, L, M, N or 1, 2, 3, 4. That is what you have to understand. Is it okay, guys? Everybody? All of you? Yes, please.
Yes, sir.
Yeah. Finish it fast. Okay. So next, the energy level which is nearest. So which is the nearest energy level? Anybody can tell? Which is the nearest energy level? E1 or E2 or E3? Which is nearest to the nucleus? Everyone? You try to tell
E1.
me the numbers. Which is nearest to the nucleus? Everybody. E1 or E2 or E3 or E4? Everyone?
E1.
E1. Yes. So that is what you have to remember, everybody. So the energy level which is nearest to the nucleus is the lowest energy. So write the next point. Point numbers, I think 6 is over 7, I think. Am I right, Amma? So 7th point. The energy level which is nearest to the nucleus, the energy level which is nearest to the nucleus has the lowest energy. Lowest energy. Understand, everybody? Next. So the order of increasing energy, if you have been taken, write it. The next point. The order of increasing energy. The order of increasing energy of various cells. Of various cells is. So which is the highest energy? K, L, M, N. Which is that, everybody? K less than, L less than, M less than N. Means compared to K, L is more energy. Compared to L, M is more energy. Compared to M, N is more energy. So I can say it's like energy levels. K means E1, L means E2, E3, E4. So what I can write? E1 is less than, E2 is less than, E2 is less, E3 is less than E4. That is what you have to remember. Is it okay, guys? All of you? Everyone? Yes? Please respond. Everybody?
Yes, sir.
Yes. So please make it. So anything doubt, please let me know. So after this, then the next point. Right. The electrons revolve. Last point. Drawback of what is the main major drawback of Rutherford? Anybody can remember and tell me? What is the major drawback of Rutherford? Electrons keep on revolving. They will radiate energy, accelerating motion. So they should fall into the what? After certain time, they have to fall into the what?
Yes,
They have to fall into the nucleus. That is what we studied. But it is not happening. That is what stability of atom is to say. So why it is happening, Mr. Rutherford not explained, but he explained here, right? The electrons revolve in their energy level. The electrons revolve, revolve. The electrons revolve in their energy level, in their energy level without losing energy. So energy remains constant without losing energy. Therefore, Therefore, is it possible to lose the energy, everybody? Therefore, it is atom will collapse? No. The atom does not collapse. Does not collapse and remains what? Remains, please respond. Remains stable. So that is only the drawback of Mr. Rutherford. So for this, Mr. Bohr's is given a point. So electrons are revolving in a circular orbits, but they are not radiating the energy. They are not losing the energy. Always energy level of each orbit is remains constant, so that electrons will never fall into the nucleus and atom is always remains stable. Hope everybody understand. Mr. Prithvi, understand? Pradhana, Darshana, any doubt you please ask. Clear guys, everyone? All of you?
Yes, sir.
Yes. So
Yes,
now
sir.
the next point, the most important point is about Mr. Niels Bohr. That is what? The arrangement of electrons. So and also he has given the maximum number of electrons which we can arrange in each orbit, right? That is the number of electrons which can be arranged, the number of electrons in each orbit, maximum number of electrons in each orbit is calculated by 2n square. What is the formula, everybody? 2n square, where n is equals to 1, 2, 3, 4, and so on. So based upon that, we will calculate now. So please write it. So first orbit, how many electrons we can fill it? So you all can see. First orbit, how many electrons we can? 2n square, n is equals to 1. So 2 into 1 square is 1. So 2 into 1 is how much, guys? How many electrons? Maximum number of electrons in first shell. Maximum number of electrons in first shell. How many, guys? Everybody? Yes, please. 2 into 1 square. How many, Ra?
2.
Yeah. So shell number 1. So first 2n square. So which is equals to 2 into 1 square, which is equals to 2 into 1, which is equals to 2. Next, 2 into 2n square, n is equals to what, everybody? Here n is equals to 1, n is equals to 2. So n is equals to 2 means 2 into 2 square, which is equals to 2 into 4. So what is the maximum number of electrons which we can fill in the second orbit? Everybody? 8 electrons. So n is equals to 3. 2n square. So 2 into 3 square, which is equals to 2 into 3 square means 9. So what is the maximum number of electrons? Everybody? Yes, please. All of you? 3. So which is equals to 18. Next, same way, n is equals to 4. N is equals to 4 means 2n square. So 2 into 4 square, which is equals to 2 into 16. So the maximum number of electrons which we can fill is how many, guys? 30.
32.
So this is what is the arrangement of electrons 2, 8, 18, 32. So 2, 8, 18, 32. So this is what is the number of electrons forming, number of electrons arranging, maximum number of electrons arranging in each shell of the orbit, each shell of the orbits. That is what you have to remember. So anybody having any doubt, please let me know. This is what is about it. Are of you clear, guys? Everybody? Yes, please.
Yes, sir.
So this is only all the 10 points is the postulates of Bohr's atomic model. Hope you all understand. Anyone having doubt, you can ask me. So please do
Sir,
it.
can you please repeat the drawbacks, sir?
Yeah, drawbacks not yet. We are going to study now. Okay. So this is
Yes,
what all about it. So now we are going to study the drawbacks of Bohr's atomic model. So let us discuss what is the drawbacks of Bohr's atomic model and how it will be rectified in the later days. So remember, now in this second point, we have mentioned nucleus contains neutrons also. That is actually updated model of Bohr's. So basically, by the time of Bohr's, there is no discovery of neutrons, because 1932 only neutrons has been discovered. Up to that, there is no neutrons known to us. Do you all understand what I am saying, everybody? So it is updated model. Sir, who updated the Bohr's model? That is what is. Nobody knows the scientist name. So the Bohr's model atom was improved by, please write it. This model was improved by a scientist name. Call it as Sommerfeld. What is his name, everybody? Sommerfeld, Field, Sommerfeld. He has been improved his model, and he has been made the corrections in the Bohr's model. That corrected model only what we are studying now. Do you understand all of it? Everybody? Clear? So by the time of by the time of Bohr's, there is no discovery of neutrons. So after, but we are studying second point. Nucleus contains what? Protons plus neutrons both. So how it will happen? It is updated model. So somebody has updated that. That is what we are studying it is. Is it okay, guys? Everybody? All of you, please respond, guys. Yes. So the Bohr's model was developed and it is further improved by Mr. Sommerfeld, scientist name. So that is what you have to remember. So this is what is all about the Bohr's model. Now we are going to study the drawbacks of Bohr's atomic model or limitations of Bohr's atomic model. So that is what you have to keep reading. So there is 2 or 3 limitations about it. So that is all. Even higher classes, 11th and 11th chemistry, you are going to get it again. So many in detail things. That is all it will be. So let us keep reading, all of you. Limitations of Bohr's model. Limitations means, remember that it is the drawbacks only. Do you all clear, everybody? Limitations or drawbacks or disadvantages, all are same. Okay, so do it. First point, Bohr is able to explain the stability of the atom. That is what is the disadvantage of Rutherford. He able to explain, but he left some things. That is what he gave a two-dimensional picture, but actually atoms are three-dimensional. They are revolving in all the XYZ directions. But he gave a two-dimensional picture. But now it has been confirmed that atoms are how many dimensional? Three-dimensional, two-dimensional. Everybody, atoms are three-dimensional. So he given a circular path. But is it true? Atoms or electrons are revolving in a circular path? No. Do you understand, everyone? So it is a three-dimensional way. He has given a two-dimensional. That is why it is a disadvantage. So first disadvantage, right? He gave a two-dimensional picture. He gave a two-dimensional picture. Two-dimensional picture means he has said that electrons are revolving in what orbits? Everybody. Electrons revolving in what path? Revolving in circular path. But now it has been proved that, but now it has been proved or confirmed that atoms are in what direction? Everybody. Atoms are what, Amma? Three-dimensional. So three-dimensional means what we used to call mathematical three-dimensional object, what we used to call? They are in spherical in shape. That is what you have to remember. Please mute yourself if there is a problem. So that is what you have to write it. So that is the first disadvantage. Understand, Mr. Lingesh? Mari, clear? Anything doubt? Please let me know. Agalya, Shivani?
Yes, sir.
Yes. That is what. Second one. He did not have any idea about the shape of the molecule by that time. So he never talked about anywhere shape. Yes, this will be spherical, this will be circular, this will be this will be that. He never spoke anywhere about it because he do not have any idea about it. That's the reason. Okay, everybody. So right, he did not have any idea about the shape. He did not have any idea about the shape of the molecule, he never told anywhere, yes, atoms will be like this, molecules will be like this. He never spoke. So that's why it is a disadvantage. Okay. So the molecule, and how are molecules are formed, and how are molecules are formed is not able to explain by Mr. Niels Bohr. And you are interested, you can learn. His full name is Niels Henrik David Bohr. What is his full name? Niels Henrik David Bohr. Niels Henrik David Bohr. Is it okay, guys? All of you?
Yes, sir.
Yeah. Niels Henrik David Bohr. His full name. Just nothing important. Just if you are interested, you can learn. Okay, everyone? That is what. So that is the second point. Whatever last next third point. He gave the concept of well-defined orbit. He gave the concept of well-defined orbit. He gave the concept of well-defined well-defined orbit, but on the basis of latest atomic theory, but on the basis of latest atomic theory, latest atomic theory, it is only the probability of, it is only the probability of, it is only the probability of finding the electrons in particular space. Probability of finding the electrons in particular space. To understand, everybody? That is what 2n square. So it is just guessing. He has not done anything. He has been defined perfectly, but it is not according to latest one. It is just a probability. It is not 100%. It is just, we can, like, what is the meaning of probability? So may or may not be. That is what you have to remember. Is it okay, guys? Everybody? All of you?
Yes, sir.
Yes. So that is the three disadvantages of Mr. Bohr's. So limitations of Bohr's, this is what. So three atomic models you have. Three atomic models are completed. So everybody has to learn. Then after this only, in the year of 1932, James Chadwick, who has been discovered the another subatomic particle, which is called as a neutron. So how he has been discovered, and why the neutrons are discovered late. These are all the things we will discuss in the tomorrow's class. And what is the properties of neutrons? And same way tomorrow we will finalize the all the things like electrons, protons, neutrons, what is the ratios, everything we are going to discuss in the tomorrow's class. So I hope you all understand. Then tomorrow we will finish this, means then directly we will go to atomic number. Then after that electronic configuration. After that directly isobars and isotopes. That's all. So this chapter. So mostly by next week we will complete it, and next Saturday we are going to go practice. So everything with the practice will complete it. Okay, everyone. So this is what is all about. So anybody having any doubt, you can ask me. So please learn these three theories. So anyhow, advance happy new year. Today is the last day of the 2023. So enjoy. Thank you, everyone. We'll meet tomorrow's class.
Thank you, sir.
Thank you.